Hey, Anshul, good afternoon. Do you want to provide a quick intro about yourself?
Uh, yes, I started off my career with data warehouse and business intelligence technology, and for last 2 years I've been working into big data. So we started it of this project with some data in the relational databases, but and when we're doing the reporting on top of that, but when we saw and realized that the data mart actually grew bigger, so we decided to push the data to HDFS through scoop ingestion. Then we created some external tables on top of that, and we started reporting. We started reporting after doing all the processing and pushing the data on a NoSQL database, that was HBase. But since the data mart was growing bigger and bigger, we were actually facing some performance challenges, and we realized to access those tables in Spark. So started processing those tables in Spark, and do the entire processing in Spark, and pushing the data and integrating Spark with NoSQL database like HBase, and doing reporting on top of that. So data is completely financial. So uh, my organization signs a contract, healthcare contract with the US citizens, and they do a customer and contact analysis on top of that. They do figure out that how many leads are getting converted into opportunities, and how many opportunities are eventually getting converted into contracts. And they are keen on identifying that what are the gray area in the contract that are not getting renewed, or they just want to send invoices to those customers on monthly basis, and do a revenue analysis on top of that. So the data is completely financial and
Okay, okay. Uh, sure. So let's take some scenario-based questions to get deeper into it, right? Let us consider that I have written a Spark job, right? And I want to monitor the progress, for the input contract feed from which I want to basically derive some analytics out of it, and for which I'm writing the Spark job. And in between, I also want to understand, okay, for how much revenue have I processed the records? So is there a way I can accomplish that in Spark, and how will I approach it?
how much revenue have you processed? So I just would like to understand it more, because uh, revenue is recognized on monthly basis. So until the entire job has run successfully, in between we cannot analyze the revenue. So we actually have to see the trend of the revenue on month basis. So it's actually a YTD value for the cumulative months we have to see. So if my
Okay.
fiscal year starts from April, and if now I'm currently if I'm working currently in June, then probably would like to see my job running for the entire June, and accumulating that data with what I had in for the past months by accumulating all those. So once the
Sure.
job has run successfully, then I will be able to analyze my YTD, year to date value. So
Understood.
for that, job has to actually run. So in between, there is no way I can monitor that what has happened, unless we tweak our Spark code to just to see the net value instead of the YTD for a particular month. So in that case, data will be quite low if I'm looking at just a 1 month value in that case. So I'll have to, if I'm the kind of business I'm currently working on, see the for YTD value to monitor, to get monitored, YTD value to get monitored. So entire job has to run. So that's the scenario here.
Okay. Let's say that I'm considering only for a month, as you said. Then what all things you will do in your Spark job so that I'm able to monitor the progress for it?
So in that case, uh, we have actually have to tweak our Spark job just to monitor the data for the month, not accumulating all the months. And we have to if you want to analyze the data, then we can actually integrate our HBase with Hive also there, because the end result has to be accumulated in some NoSQL database for reporting. So there I can integrate my HBase table with Hive, and if you want to just monitor the data for a month, we can actually do a quick grouping operation on Hive, and see that what I'm getting there.
Okay, okay. Sure. Uh, how comfortable are you in terms of HBase?
So for HBase, the kind of operation I have done is just ingesting the data into HBase. So that's
Mhm.
all the operation that I've done.
Okay, okay. Can you help me understand the architecture of HBase and what are the components? Why are they required? What is the use case for it?
Sure. So for HBase, HBase has got a very complicated architecture, because it has a zookeeper and H master, and some region server which contains the write ahead log, and write ahead log and mem store. Inside that we have some uh, um, inside that we have some column family which contains the block cache and H file. So this is the architecture of HBase. So Zookeeper is something which receives the heartbeat signal from the H master and region server, and region server while region server contains the server contains the write ahead log, that is for the recovery during the write operation. If I'm writing it to HBase, and if I lose my data, then I can recover it from the write ahead log. And besides that, I have actually um, a block cache which contains the frequently read data. So if I'm trying to read it from HBase, it will first look into the block cache, then it will go to the mem store, then eventually it will go to hash file. And so mem store is something that is used to perform the write operation. So whenever I'm writing the data to HBase, it gets stored initially in mem store, and when the mem store gets full, the data is flushed to H file.
Okay, okay. And what are major and minor compactions in HBase?
So there are actually two compaction techniques, which are major and minor compaction. So what happens when there are a lot of batch files? So it actually slows down the read performance, and there is a lot of inconsistency. So we combine uh, um, uh, those small H files to some larger files, and it has some good number of it has some good number of H file in that case when we combine it. So that is called minor compaction. And when we do it for the entire uh, uh, region server, region server, there is one H file. When we make it up just one H file, then it actually becomes the major compaction.
Okay, okay. So Anshul, I'm sure that you would have interacted with HDFS during your tenure, right? So when you interact
Mhm.
with HDFS normally using CLI, at least what I have seen and what you would have seen as well is there's a lot of latency in terms of getting the IO from HDFS. While on the other hand, when we say for HBase, HBase is storing its data on top of HDFS only, but HBase is able to give us microsecond latency. So what exactly is happening when I submit a query on HBase that it is able to give me a microsecond latency? While if I'm trying to do that similarly on HDFS CLI, I'm not able to get similarity.
So HDFS, the way the data gets stored, HDFS is not efficient for searching. So HDFS is never a database. While when you talk about or while you talk about the NoSQL database like HBase, so it stores the data. It stores the data in optimized way using the row key, and row key, which is very much helpful in retrieving the records on a very quick basis. Although it does not fire the map reduce job internally, so that will enable us to fetch the data in a very fast manner.
No, even when I try to ask for a text file from, say, HDFS CLI, there's no map reduce job which is getting invoked internally, but still the output is in seconds. And on the contrary, in case of HBase, I get it in milliseconds. So what exactly is Roki doing in this case that it is helping me out to pull the data from HDFS, that too in milliseconds?
Now, so there is a row key implemented inside. This is basically a read operation, right? So
Mhm.
what is happening? Whenever there is a we need to understand the internal architecture of the space in that case, because whenever we are going for a read operation, so it will actually go to the it will go to the H master to find the location of the meta table. So when user caches that meta table, so um, uh, user can go to that meta table and query for the corresponding region server, and that region server get the block cache which has already the frequently read data. So if the data has been queried before, it will give you at that point of time only, at that instant. But even if the data is not there, it will go to the H file and bring that data. And in the H file, the data is again arranged in a block, and that too in the that lightweight index is implemented in terms of row key. That will help you to fetch the data very quickly.
Okay, okay. Uh, cool. Okay. Can you help me understand how are stages and tasks determined in case of Spark?
Stages and tasks. So these tasks are nothing but all the lambda functions that we write in Spark. But when you talk about the stages, so whenever there is a data shuffle in Spark, it corresponds to a new stage. So each shuffling of data will actually create a new stage at that point of time, which is a very costly operation because data has to be serialized and then deserialized. So that causes the creation of stages.
Okay, okay. Can you quote some examples of the operations which span across stage boundaries?
Yep, of course. So there are wide operations in Spark which causes the creation of stages. For example, when you talk about the reduce by key, which is a wide operation, so data needs to be shuffled across various partitions. And another example could be group by key, where the same keys are grouped into a partitions. So there is again would be a data shuffle. So data will be written to a disk, data would be read from the disk. So data is getting serialized, and at the date time while being read, it is being while being read for the second time, it is being deserialized. So this is causing the creation of stages. So these are some transformations which are wide, which will cause the creation of stages.
Sure, sure. Okay. Let's say that I have written a Spark job. Okay. Now, in my Spark job, normally, if you see, I have some RDD operations, reading from a text file, and then running some map filter, some reduce by, and then dumping that back into HDFS. Okay. Now,
Mhm.
if there is a way I am able to like get into the process which is running, then what all references do I expect to see in drivers, and what all references do I expect to see in executors?
Uh, can you just help me understand what references do you mean here?
So all the Java object references. So primarily from that Spark job perspective, like wherein you are
Mhm.
creating an RDD by reading a text file, you have a Spark context. So Spark context is one of the reference, RDD is another reference. and any other references which you can recollect while executing a Spark job, and which all references will I be seeing in driver, and which all references I'll be looking at in executors.
So all the actions that you have called will be the part of the driver, and all the lambda function which executor is executing will be up to executors. So
Okay.
lambda functions could be like any transformations that you're using or any higher order function that you're using. So executor would be accountable to execute those.
Okay. Can you help me understand how accumulators work in Spark?
Accumulators are the variables in Spark which all the worker node can write in, while the drivers would just read that variable. So that variable is being written by all the worker nodes. So and after writing all those variables, those that particular accumulator is being is read on the drivers nodes. So that's how it works.
Okay. Okay. And yeah, that makes sense. Let's say that I am trying to join two RDDs. Okay.
Mm-hmm. All
Uh,
right.
uh, However, the join during the joining process, what I see is that the performance is uh, not very optimized. So it is taking much amount of time as against my expectations. So what could be
Hmm.
the reason, and how can you help me out here?
Now, actually, there could be two possible reasons that I can think of as of now while joining. So, let's look at the size of the RDD first, because if the RDD is created on top of a very small data set, and we are joining it with a very large data set. So data is actually it is actually getting partitioned across various nodes here. So if one of the RDDs that I find is small, then that can be broadcasted instead of getting partitioned over various nodes. So using the making use of broadcast variable can enhance the performance in this case, because the broadcast variable is never partitioned, it is actually transmitted or broadcasted over a network. But in case if we are joining two big RDDs, let's say that they are two big tables, if we talk about a big tables, then we can use probably a kind of partitioner. In that case, we can use something like that partition by a hash partitioner, so that the partition for the same key it always hash partitions actually points to the same partition always for the same key, so that data shuffling would be least in this case. So this is the way these are the two ways I can think of optimizing the join operation in this case.
Sure. Okay. Can you help me understand what is the difference between standalone clusters and yarn clusters? And what is the value proposition which I will have if I use a yarn cluster?
So when you talk about the yarn clusters, so the mode is actually the cluster mode. So uh, what happens when you submit the job? The driver program. The driver will start the application master, and application master will act as an executor launcher here. But when you talk about the client mode, uh, so application master itself starts the executor, not the driver. In the cluster mode, when you are running on top of yarn, which is spinning off the application master, internally it will start the driver, and the driver will be the executor launcher. But while in the previous case the driver was running in the local machine, so that's the difference between these two.
Okay. Okay. Uh, cool. Do you have experience with streaming data, Anshul?
Uh, Not much, Ashish. I just have integrated Spark in one of the projects with streaming data while I was reading JSON. So I had to create the producer, and the consumer was my Spark application, and I had to convert into the structured data frame, and I had to do some analysis on top of that. So I do not have much experience on streaming data.
Okay, no worries. By any chance, do you know what is back pressure?
I'm sorry, I'm not aware of this.
Okay, no worries. How comfortable are you with Kafka?
Not much. I just have started learning it, so not very much comfortable with that.
Okay, okay, no worries. Uh, let's say that I am writing a MapReduce job, okay? And
Mm-hmm.
what I want to accomplish is I have a text file which I'm trying to read. And in that text file, what I want to basically get the output is what is the delta between the current record and the next record, immediately next record.
Mm-hmm.
So how will you accomplish that in MapReduce?
So I don't know to do that in MapReduce, but I am aware that how can this be achieved in Hive. So using a
Okay,
lead or lag function, I can use a lead or lag function in Hive to achieve the same.
okay, okay. Uh, can you help me understand what is the difference between rank and dense rank?
So dense rank is will do the ranking, and on the same rank it will not skip the rank, but rank will on the same ranking it will skip the rank and start from the next number onwards.
Sure, sure. Okay, okay. Uh, let's say that I have a Hive table with me. Okay.
Mm-hmm.
Now, in that Hive table, I have around 100 columns available, and I have historical data stored in that table. Now,
Mm-hmm.
what if I say that you have to devise a deduplication pipeline, right? And that deduplication pipeline will consider if any of the two records are 90% overlapping. So when I say 90% overlapping, out of 100 columns, let's say that 90 columns are matching, any of the 90 columns are matching, then in that case, you have to apply the deduplication and consider only one of the records. How will you approach this? How will you devise your pipeline so that it is optimized?
Uh, so 90% of the columns are matching. So that means that 90% of the columns have the same value. Any 90% of the columns,
Yes,
and it has 100 columns.
yes.
Just give me a sec. Let me think through it.
Yeah.
But I can think of a solution, but I don't think that is optimized because I'll have to write all those 100 columns in left outer join,
Okay.
and we'll find that which of the column is not matching.
Okay.
But not very sure
Any,
about it because it
yeah.
will
Any other
let
approach
me
which you
write. Sorry, Ashish, come again, please.
yeah, can you think of any other approach?
Um, Not now, Ashish.
Sure, no worries. Uh, what if you were to accomplish this task in Spark? How will you accomplish it?
I would use the same approach because I can create a data frame there, but I really cannot think beyond using joins here.
Okay, okay. No worries. Anshul, can you help me understand what is RDD?
RDD is actually are the distributed in-memory objects.
Hmm. Okay, would you care to explain further?
Yeah, so it is resilient because due to the lineage property and due to the immutability, and distributed because once you read it from the file, it gets distributed not across the disk but across the RAM of the system. So this is why it is called resilient and distributed, and it has come from the data set. So it's a resilient distributed data set in that case,
Okay,
in-memory collection of
and
objects.
sure. Okay. Can you help me understand in what cases would RDD be faster versus data frame or dataset?
Uh, RDD can be faster in one of the cases when we specify maximum information about the RDD. That data frame and data set infers automatically. For example, if I'm reading a text file which I am creating, which I am creating RDD from, then I can specify a case class and provide maximum information about that, including the data types and all those. So that is one case where RDD can be faster.
Okay, but wouldn't that internally convert it into a data frame or dataset and then process it?
Plain RDD cannot be directly converted into dataset unless we specify the schema on top of that.
But you already mentioned that you'll create a case class, right?
Yeah,
Yeah. Will it not help me to convert an RDD to a data frame or dataset?
yeah, that will help you to convert into dataset and data frame.
Okay, okay. Uh, Anshul, as part of Spark 1, we had something called as Spark Context. In Spark 2, we got something called as Spark Session. Can you help
Mhm.
me understand what is the difference between the two?
So Spark context is the entry point of the Spark. It's very similar to like a database connection. So that whatever we do using connection that can be served with the help of Spark context. So it's a gateway to Spark functionality, I would say. While Spark session is created was introduced in Spark 2, and which is acting as a wrapper on top of its Spark context. So that is a umbrella on top of the context, and which can help us in consuming all kind of context, whether it is Spark context or the Hive context, the SQL context. So it's an umbrella on top of that, which wraps the Spark context and other contexts.
Sure. Okay. Let's say that you are an architect, okay? And normally it is recommended that you use ORC format for your data if you are trying to query it using Hive, and Parquet if you are trying to query it using Spark. Which
Mhm.
one would you follow in this case? If you were to store it, and how will you visualize? How will you arrive at a decision in this case?
So uh, ORC specifically, or it's very well, I would say, very well blends with Hive, uh, and because it has the compression techniques and the variable compression length and uh, it a variable compression length and the optimization that it does while searching the records, while skipping the irrelevant stripes and all those. So that is beneficial in Hive. But while using Spark, I'll go for Parquet. I would say the reason is the data type compatibility. For example, the timestamp data type would not support great in Parquet, while it will support in ORC. So for the data type compatibility, Spark would be best fit for Spark, while ORC would be the best fit for Hive. And also, when I'm trying to handle the nested data, Parquet would be the best choice in that case. In Spark.
Sure. Okay. Okay. Cool. Let's say that I have XML data which is coming from upstream. Okay, and I want to create an Hive external table on top of it. Do you think that is possible? If yes, then how?
That is possible, but Hive does not support the XML direct, the data that is coming in format of XML to be converted into Hive tables. So for that, we'll have to download a SERDI, and there are some properties that we have to set along with that SERDI, and we can read the data into Hive tables in proper tabular format. So a SERDI is required for that to be
Okay.
downloaded.
Can you help me understand what is the difference between SERDI and input format, output format?
SERDI is basically when the data, SERDI is the serialization and deserialization part of the data. When it is actually getting written to disk, it is getting deserialized. So when I'm reading it, when I'm reading it from the disk, it's get deserialized. So it's basically it's actually the network. It's related to the network when you are pushing the data into a storage and when you are reading it from, while input and output format is something that you get that uh, input and output format is something that you get that what kind of format it is while reading the data and what format it is when you are uh, actually writing the data into HDFS or any storage.
When I mentioned that it is a text file, wouldn't SERDI, what would SERDI do in that case? What would input format do in that case?
Uh, SERDI will so serialization will uh, actually convert the data into bytes and it into HDFS, while the deserialization part will convert that bytes again into a readable format using object inspector, and will help us in reading the data, while input format is the format that we supply while serializing the data, or output format is the that is the way we read the data from the storage.
Okay, okay. Uh, uh, let's say that I have a Hive table and I'm trying to run a query on top of it. Somehow I'm getting out of memory errors in that. How will you fix that?
Out of memory. So it is happening while processing the data or just reading the data from HDFS.
While processing the data?
Yeah, it should not happen while reading the data, I guess, because you are reading from it from HDFS. So while processing the data, it is happening. That might be happening because a lot of keys would have got accumulated in one reducer. So you might be getting memory out of exception in that case. So we can do it by using we can do it using the sorting technique, where we can attach some random numbers. We can attach some random numbers to the column, and that the hash function will eventually distribute those keys into different reducers instead of going to the same reducer. So that will help in distributing the keys evenly across the reducer, and probably you will not get the memory out of exception.
Okay, but wouldn't that break my group by query, which I have already written? And if I am adding a random number to each of the grouped key, then in that case, how will I be able to aggregate?
I got your question. You are saying if the split has gone to so many reducers, and if each key is doing the reducer at its own level, it will be difficult to see the final aggregation.
Yes.
That's right. Uh, in that case, we can take the partially result and we can push it into relational database, because after the data has crunched properly, then I do not require a big data system in that case. So I'll go to the traditional relational database system and I'll remove all the keys and do the grouping operation there after I have got a small subset of data in the big data process.
Okay. Okay. Uh, let's say that I have one Hive table and one HBase table. I want to join the data between those two tables and dump it into third Hive table. What tools will you use in this? What minimalistic tools will you use in this?
So I'll create one Hive managed table or Hive managed table on top of HBase, and then I'll join it with another Hive table. And using create table as a statement, I can push the result of that join into that table.
Sure. Okay. Okay. Cool. Anshul, I think I am through. Let me pause the recording.
Okay.